Alright, now we're going to do, we're going to show you the system of substitution. To me, honestly, substitution sometimes is just a little bit easier. So let's say, for example, we have 2x plus 3y equals 8 and x minus y equals 2. How can you do this for substitution? What you do is you're going to take one of the equations. It doesn't matter which one you take. And you're going to solve for y. So let's say that we take the second one, which seems just a lot easier. It doesn't have any coefficients on it. So you take the x minus y equals 2. And we're going to solve for, the x is a lot easier because all you got to do is add the y. And we have that x is equal to 2 plus y. Okay? What we're going to do is we're going to substitute in. So we started with the second equation, right? So because we started with the second equation, we have to substitute this into the first equation. The first equation was 2x plus 3y equals 8. But x is 2 plus y. So 2 times 2 plus y. Wait, let me use different color here. For the x, we're going to do 2 plus 2y. Okay? And then you have plus 3y equals 8. So what I did was, for the x, I substituted 2 plus y. And then so we're going to distribute. And you get 4 plus 2y plus 3y equals 8. 4 plus 5y equals 8. Subtract 4. 5y equals 4. And we divide both sides by 5. We get that y equals 4/5. Okay? That's the first one, but then we have to solve for the x. And then this is where this comes in handy. You know that x is equal to 2 plus y. So x is equal to 2 plus, what is y? 4/5. And so this is a fraction and this is a number, so you have to put that into common denominator. 2 plus 4/5. So we said x is equal to 2 plus 4/5. And so in order to get this to be a 5, we got to multiply top and bottom by 5, right? Oh, that didn't come out well. Hold on. Okay, this is 2 over 1. And we want a common denominator. So we're going to multiply top and bottom. We want a common denominator, so we're going to multiply top and bottom by 5. So then this becomes 2 times 5 is 10 over 5 plus 4/5. So this is 10 plus 4 over 5. That means x is equal to 14/5. And we had that y is equal to 4/5. And that x is equal to 14/5. And so because there is one solution, what kind of system do we have? We have a consistent and independent system. Okay? Alright, so we're going to continue just basically practicing. I already showed you both techniques, so which technique you use is up to you. So there's nothing that says that you always use, in one case you have to use substitution, in the other case you got to use elimination. You can use either one and they will both help you get the answer. So you call it as you see it. We're going to go ahead and try to solve the system, and what I'm going to show you is one of the special cases. Alright, so I look at this and I see a positive 12x and I see a negative 6. And I think if I multiply that negative 6 by 2, I get a negative 12. And 12 plus a negative 12, it's going to be 0, which means I can cancel out that x. So I'm going to go for it. I'm going to take this second equation and I'm going to multiply by 2. But remember, when we do this, we have to distribute it to everything. Alright, I'm rewriting. I have 12x minus 13y equals 2. I just rewrote the first equation. And my second equation now becomes 2 times negative 6 which is negative 12x, 2 times 6.5, which is 13y, equals 2 times negative 2, which is negative 4. And so I'm going to combine the equations, all right, going down. The 2 and the negative 4 become negative 2. The minus 13y plus 13y, they cancel each other. And the 12x minus the 12x, they also cancel each other. So I have 0 equals negative 2. Now, which case do we have? Does this make any sense? No. So when the answer doesn't make sense, you have the case of no solution. Okay? No solution. So this is the inconsistent case. Remember, this is the case of the parallel lines. And that would be the answer right here. No solution. This is your proof. Right. This would be another system. 12x minus 3y equals 6. And 4x minus y equals 2. And like I said, there is no right way or wrong way. You just pick whichever system you want. Whether you want to use substitution or whether you want to use elimination. I'm going to go for elimination because I see this, I see the minus 3y, and then I see the minus y. And that minus y, if I multiply it by a negative 3, I get a positive 3. And minus 3 plus 3 is 0, which is what I'm looking for to eliminate. So I'm going to take the bottom one and I'm going to multiply by a negative 3. When I do that, I have to remember that I have to distribute it to everything. Alright, I'm rewriting the first one. So I have 12x minus 3y equals 6. And then negative 3 times 4 is negative 12x. Negative 3 times negative 1 is positive 3y. And negative 3 times 2 is negative 6. And I'm going to combine this from top to bottom. 6 plus a negative 6 is 0. This, right, that cancels. This also cancels. And this also cancels. So I have that 0 equals 0. 0 equals 0. But both sides are the same. So which case do we have? This is the case of the lines overlap each other. Like it's the same line, literally. Alright, so this case is consistent. But it's dependent because they overlap. And that means you have an infinite number of solutions. That means any x value will do. It is not limited. Right? Any x value will do because they all sit on the same line. They touch everywhere, basically. So there's an infinite number of solutions. And that would be this case.